Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the introduction to Fragment Test. But first, let's talk about the scenario in which we can employ this particular non-parametric method. So here, the idea of having, for example, two dependent samples, so this is a very basic idea, can be easily extended or generalized to having more than two dependent groups. For example, you can have 3 groups, 4, and so on. So in the dependent samples or dependent groups, the key idea is that we have the same subjects that are going to show up in each group. And in other words, this is called the repeated measures. Well, for example, here we have two types of possible repeated measures. So here the measurements taken across different time points. For example, does a particular procedure, so we have one specific treatment here to clean up drinking water, effective? So the question is asking whether a treatment given to drinking water is effective. In order to investigate that particular treatment is effective or not, they take the sample of 12 counties and the drinking water were compared using samples from different time points. So you can see here they took the sample before cleanup, 1 week later, and 2 weeks after cleanup. So that is the example of measurements being taken across different time points. Now the next example is you have measurements taken from different treatments. So the word treatments here is very general. Actually, it can mean totally like really truly different treatments. For example, different drugs are given to a certain patient, drug A, drug B, or drug C. It can also mean different methods being applied to the same subject. But it can also mean different conditions. So the example of different conditions is given here. For example, does the public associate different amounts of prestige with a doctor, lawyer, police officer, and a teacher? So here we have 4 different treatments or conditions, and the sample here is 10 people. So 10 people here will be given their opinions related to what they think of these 4 occupations here in terms of the amounts of prestige. So let's try and envision how this data will be presented. Okay, so this is what I'm going to illustrate. So for the first example here, again, what's the example? Okay, so here we have, for example, our subject is county, and we will have one particular treatment to be investigated, and they take measurement at the baseline after 1 week, after 2 weeks. So something like that. This is how your data is going to appear. So we have county 1, 2, and up to 12. Okay, so here is up to 12. So you can imagine your data will appear like this. X for sample 1. So this is the measurement after 1 week. This is the measurement after 2 weeks. So we can imagine different number of data, different number of measurements here. So similarly, x2, okay, so different value, and so on. Okay, so that's how your data can be represented. What else? The second example is well, we have different people, and they are going to rate all these occupations. So this is 1, 2, up to 10 people. They're going to give their opinions regarding the amount of prestige for doctors, what else, lawyers, police officers, and also teachers. And here their values can be written as such. It could be x1 1. Okay, so this could be the value given, okay, to all this occupation. This is for the second person. They will have their own set of measurement. Okay, so something like that. So the key word here, again, let me emphasize again on the word, on the key idea, so on the key idea. Same subjects will show up in each group. So that means the measurement here is given by the same subject. This one is given by the same person. This one is given by the same person or same subject. So for this one, it comes from the second subject or second person. Also comes from the second person. This also comes from the second person. So that is the key idea here. All the measurements here, all the data set in each group, they actually come from the same person. Okay, same person or same subject. Okay, so in this scenario, so when you have dependent samples or when you have repeated measures in this case, the interest is to test the null hypothesis that 3 or more repeated samples are equal. So what does it mean? So when they are equal, that means, for example, if you look at this example here, when the results are equal, when the groups here are equal, it means the treatment for drinking water does not work, because the results here are equal for each group. So that means when you have the null hypothesis of equality in 3 or more repeated samples, that means, in other words, it means that treatment of drinking water does not work. Because if it works, then you will see some differences after 1 week and 2 weeks. Okay, so that's the idea. So similarly, if you are talking about the null hypothesis of the keyword here is equality, so that means people will think that all the occupations here have the same prestigious, have the same amount of prestige, for example. So that is the meaning of equality in this particular example, in this specific example. Okay, right. Now the parametric procedure for this is ANOVA for repeated measures, but as always, we know the parametric procedure requires certain assumptions that sometimes could be difficult to fulfill. For example, the distribution of the response variable is normally distributed. So when we find that we are in this particular situation where the sample size is small and the normality assumption is not fulfilled, then you have an alternative approach, which is using the non-parametric counterpart, and the method here is known as the fragment test. So the assumptions for fragment test are given as follows. For example, we need the sample is actually a random sample that you get from the population of interest. The subjects in this group are measured on 3 or more different occasions. This is what it means by the same idea that is given here. The same subjects show up in each group, repeated measures. So the second point here is exactly related to the key idea which I have described just now. Measurement scale is at least ordinal. You have similar spread across the groups. This is particularly important if you want to be more specific in the null hypothesis. For example, you want to test the medians. And here blocks are mutually independent, or the pairs are independent. So what it means by this particular assumption is blocks in particular refers to this part. So here is the blocks. The first block, this is the second block, and this is the 12th block. Similarly, this is the block, because all the measurements here come from one subject or one person. This is also the block. Okay, so all the blocks here, each block, so block 1 is independent of block 2, is independent of block 12, and so on. So all the blocks here are independent. Basically, that is what it means. Okay. Now, in terms of hypothesis statements, the simple way of doing it, of course, you can actually look at the question asked and come up with the hypothesis statements related to it. But I think there is a specific way of doing it. So here, specific way means there is some sort of a structured way that you can do, you know, if you find it difficult to write the hypothesis statement. So here's the idea on how to structure your hypothesis. So the first one is, when you write the null hypothesis, the keyword here is there is no difference. No difference. And for, sorry, this is alternative hypothesis. The word here is different in at least one group. Okay. So the blank space here is for you to insert whatever variable of interest that is asked in the question. So this is whatever variable of interest or whatever the question is asking you to find, okay, the measurement and so on. So don't worry too much about this. I think you will get the idea when we do the practical example in the next video. Okay, so next one, let's move on to how can we get the test statistic. So here, for each subject, rank the observations within blocks. So what it means here, so pay attention to this part. When you rank the observations, you will rank the observations according to block. So here will be your ranking. The highest one will get ranking 1. The lowest will get 2. This one will get 3, for example, if this is the highest one. Okay, and then you move on to the next block and you rank it again. If let's say the lowest value is over here, you will get rank 1. Maybe this is the second, a bit higher, so this get 2, and this is the highest, so you will get ranking rank of 3. Okay, so ranking is done again within blocks. And if there are ties, the procedure is the same as we have discussed in cross-cohort list, for example. You will give them the average of the ranks that they would have obtained had they been different from each other. Next part is you have to obtain the sum of ranks in each group. So once you have managed to rank all the observations, the sum of ranks is done in this according to the group. Okay, so you will get the rank for group 1, and you get the rank, the sum of rank for group 2, and then the sum of rank from group 3. So here you will sum up all the ranks that you have obtained in the first step. Okay, so here is the sum of ranks in each group that you have. And this is called Ri. And why do you need this? Because we need this in the formula to calculate the test statistic. So this is Ri given right there. And N here is the sample size. Notice that the sample size here refers to this part. Okay, so we have 12 sample size. Because this sample size here again, all the measurements that you see in each group here comes from this same subject. So total sample size is just 12, or total sample size is just 10. So this is our N. Okay. K is the number of treatments or samples or groups. So what is K? K refers to this part, the number of groups, the number of groups or treatments or conditions and so on. Okay. Now, to decide whether the null hypothesis should be rejected or not, you are going to use table of chi-square distribution. Note that this for sample size bigger than a certain number, for example, when sample size is large and k is large, you can use chi-square distribution, but this result is going to be not exact when the sample size is small. But that is not going to be discussed here, so you will see that in the next video. In the practical example, we will just incorporate the use of chi-square distribution in our decision process. So here we're going to reject H null at significance level alpha if the test statistic is greater than the critical value given in the table. So here is our test statistic. If it is greater than the critical value, then you reject H null at that particular significance level. Okay, so here is example of chi-square distribution, and I think we will stop right here, and I will continue in the next video with this practical example. Thank you very much for watching, and I'll see you then.